Hey everyone, my name's Chris and I'm an onboarding engineer here at SkyCiv. And today we're just going to be walking through a tutorial on how to check a custom concrete column using the SkyCiv General Section Designer. So for today's tutorial, we've got this example here prepared. So having a look at this, we've got an 18-foot tall concrete column with cross sections shown is subject to the following loads. So we've got a permanent compression load of 150 kip, lateral load of 10 kip along the x-axis, negative 24 kip along the z-axis. And it tells us the column is a cantilever with a fixed base and the loads are applied at the top of the column. So it wants us to check the column for deflection with a height on 200 requirement there and complete a section check on the base of the column. Right, so jumping back to our SkyCiv dashboard here. So the General Section Designer, it can be accessed both through Structural 3D or directly in the section builder. But because today's example, we want to actually model in the column, we're going to use Structural 3D. So we'll just launch that now and start a new file there. So jumping back over to our problem here. So just get a few details here. So we've got an 18-foot tall concrete column. And the column is a cantilever. We've got a fixed base, and the loads are applied at the top of the column. So that's all handy info for us to know. So we'll start off by modeling in the nodes. So we'll just hit nodes there, and then starting off, we're just going to create a node at the origin, so 0 for everything, and then we're going to make this 18-foot in the vertical axis. So vertical axis is the y-axis there, and we hit apply. So we've got our two nodes for the column, and we can just click and drag between these two nodes and create our member there. So now that we've got our member modeled in, we can go ahead and create our fixed support for the column. So we'll just select that node 1 at the bottom there, go to our supports menu. We can click this little button here, which will drop that node in. And then by default, we've got this fixed support restraint code already assigned. So we can just go ahead and hit apply on that. And as you can see, that's now applied fixed support there. The next thing we can do is apply our loads. So we'll just jump back over and check what loads we're going to be putting in. So it's got two separate load groups that it wants us to put in. So we've got a permanent compression load of 150 kip. So what we're going to do, we will go to point loads, and we're going to be applying it at the top of the column. So we'll go node 2 here, and this is a compression load. So we're going to be going in the negative y direction, 150 kip. And I'm just going to rename this to be in line with the problem. So we'll call this permanent, so we can keep track of that. And we'll just hit apply. And you can see that we've now got that 150 kip load there. So the next one we're going to apply is our lateral load. Our lateral load consists of 10 kip along the x-axis and just 24 kip along the z-axis. So we'll just go back this way. So what we're going to do is node 2 again, and we're going to put 10 kip and 24 kip in the z direction there. And we might call this lateral. We'll go apply. And you can see that that basically creates a resultant point load from the two components there. And that ends up equating to 26 kip. So a couple of other things that we're going to do, we're actually going to apply a self weight as well. So we'll just go self weight and turn this on. And that defaults to -1 gravity in the y direction. So we'll hit apply on that. And we're going to create some load combinations. What we'll do here, we'll just create a strength case, and I might go 1 for the lateral factor, but 1.2 and 1.2. Just depends on what your code or what you're trying to analyze for those factors there. We'll hit apply on that. And then I'm going to do a deflection case as well. We'll change this to a serviceability criteria. And I might factor this down, let's say 0.7. I'll leave these permanent loads as a factor of 1, so we can hit apply on that. So now that we have created those loads there, we can actually go ahead and create our section. So what we're going to do is we're going to click our section button here, and then we're going to go to the section builder. And there's a few options in the section builder. If you had a standard shape, we've got all these standard shapes that you can use, rectangular all the way down to some different Z shapes, channels. We've got some standard database shapes, but for this particular application, as we've got this tapered shape that we're using, I'm actually going to use a custom shape. So there's a couple of ways you can use custom shapes. So we can either have a point shape, we can have a line shape, or if you've got something that you've created in CAD, you can actually import a DXF file, and you might find that easier for something very customized. So for my particular example, I'm going to use this point shape. So I'll just click that, and you can see it comes up with this default hexagonal shape here. So let's have a look at what shape we're going to be actually doing. So yeah, we've got sort of this trapezium shape. We've got 20-inch wide base, 36-inch long, and then 10-inch at the top. We're going to assume that this tapers in at an even angle. So basically what we'll do, we'll jump into here, and these points are controlled in this table here. We've got a Z and Y coordinate, which corresponds to these axes here. So basically what we'll do, we'll just start to modify this data here. So I only need 4 points, so I might delete the bottom 2 here. But what we'll do, we've got 0, 0, and then our next point will be 5 and 36. And then we'll have 15 and 36. So we're sort of going around this way. And then our final point will be 20 and 0. And if we hit submit on that, you can see that we've got a pretty nice match there, but we've still got these curved corners, and that's just controlled by this radius setting here. So we actually want to set this to 0. We'll just keep changing these to 0 there. Hit submit, and you can see now we've got those sharp corners there. So we can actually hit calculate on that if you wanted to check the section properties. The only other thing to do, we'll actually assign a material as well to this. So what we'll do, we'll click on this, go material, and then we want to assign, we'll make this a concrete material, and we're going to go general. And for this, we'll use 4,000 PSI concrete. So we'll just select that and go submit. You can see that's now updated there. So we've created our section, updated our material, and we can now hit submit on that. So you can see that this is now applied. You can see, because we didn't have any other sections assigned, it defaults to the first section we define. We'll have a look in the 3D section here. So we can actually see that our columns currently, based on our loads, it's actually rotated the wrong way. So what we can do to rotate this, we select the member here, we can now rotate it around using this angle of rotation input. So I'm just going to go -90, and then I'll check the 3D again, and you can see that that's now matching the same way that we put this in based on these loads as well. So we're happy with that. And now that that's matching there, the final step that you may be interested in, depending on your particular application, we're going to look at some stiffness reduction factors for our members. So we just go to edit members, and we've got section reduction factors here. Now for my particular example, I'm going to actually choose to reduce the moment of inertia by a factor of 0.7 for both the Y and Z moments of inertia. Now this depends on what your code specifies, or depending on the different application that you're trying to check. But for this example, yeah, I'm going to set this to 0.7. So we're applying this to section 1. And basically all this will do is in the analysis, it will reduce the gross section moment of inertia by that factor. So I'm going to leave these other factors as they are. I'll just hit save on that now. You can see that it says that's been applied. So we're now ready to run our analysis for our column. So we'll just hover over here to the solve button, and we're actually going to run this as a nonlinear static analysis with P delta. So we want to capture that P delta effect. So we'll hit that and that'll run. And that's solved successfully. So we can hit OK. And we can have a look. Let's have a look at our deflection check. So our problem specified height on 200 for our deflection there. So we've got 18 feet, which equates to 216 inches. So if we go 216 on 200, we've got a deflection limit of 1.08 inches. So if we hit displacement and we do the sum, we can see we're just scraping in. So we've got 1.005 inches. And again, our deflection limit was 1.08 inches. So we're passing the deflection requirements there. And then we switch over to our strength case, we can see some of our moments lying on the column here. So that's kind of handy to look at. We can see our reactions, depending on what you wanted to do with that, different shears. So using the General Section Designer, what we can actually do, we can right-click on this result here, on this member, and we click the Launch Section Designer. And the advantage of doing it this way is it'll actually take these calculated design actions directly from the solve and transfer them straight in. So we'll click that now, and it asks for the member ID, and that's saying that it'll use load combination number 1, as that's what we're using. So that's correct, because that's our strength case in this scenario. So we'll go launch GSD. And you can see that it's actually the section builder that hosts the General Section Designer here. So in the right here, we've got the General Section Designer menu that we can control here. And starting off, we've got the concrete material settings. So it's got these different design codes that we can pick from. Quite a few options there. For this one, we might use ACI 318. And we know that our concrete strength is 4,000 PSI. So we'll choose this C4000. And then down here, it's got this stress strain diagram data. Basically, this will default values for these that you choose. But if you wanted to choose something custom, maybe you had a custom concrete that you're going to use, you can import that and you can see that diagram data there. But we'll leave that as a default for now. So we can move on to our next menu item there, which is the rebar material. And again, we've got various design codes that we can choose from. So for this one, again, we'll use ACI 318. And we might use grade 60 steel for this. And again, we've got this stress strain diagram data. So you can draw that there, or you can put custom data in there if you've got something custom that you're working with. But again, we'll leave that as the default values for now. And the next one that we're going to move on to is actually putting in our rebar into our section here. So there's a couple of ways that we can assign these. So we can either individually place the bars, or we can drop them in as a line, and we interact with the section directly in here to put those in. So we might put 5 bars along each side for this example, and we'll leave this default, that's a number 7 bar there, so 7/8 of an inch. Starting off with this point bar assignment, basically what we do, we just individually click our bars into the section here. You can see that it adds to this table data as we go along, and we can change those coordinates. So I might tweak those slightly so that they're a bit more evenly spaced, and we might base it on roughly around 1.5 inch of cover. So we'll go, I'll just put some values in, 6.5 and 34.5, 5.25, 26.25, 4 and 18. You can see that they move as we change the data there as well. So 2.75 and 9.75. And finally 1.5 and 1.5. So that's how you use this point bar assignment option there. Otherwise, we've got this line of bar option. So we just roll that on. It's got these info tips as well if you ever needed to refresh that. Basically, we'll leave this bar diameter as 0.875. We're going to include the start and end bar and have 3 intermediate bars. And then like this diagram, basically we're going to pick the start and end point of the line. So we'll go over here and we'll go the start point here and an end point in the bottom corner. And you can see that it drops those bars in. And then basically we can modify the coordinates. So Z1, Y1 is the coordinates of this point, and Z2, Y2 is the coordinates of the second point. So we might slightly tweak those to reflect the other side as well. So we'll go 34.5 here. Leave that as 13.5 there. And then 18.5 and 1.5. And yeah, we've got pretty much just line of symmetry there now. So what we can now do, next menu here, we've got section loads. So you can see from our solver that we've actually got our design actions for each point along that column have been automatically transferred into this here, so we don't have to manually add those in. So that's nice and handy. We can add extra points if we want. But basically, yeah, we can see here is our worst one. That correlates to the base section that we're interested in. But yeah, we can leave that for now, and we can now go to the analysis tab and pick from a design code. So again, we've got a variety of design codes there, but for this one, we'll go ACI 318, and we can just click Run Analysis. So that will now run. And you can see that basically we get these results here. We can see these were the different loads that were assigned at different points. So this load ID 1 would correlate to our base section there. And we can actually see that we've got a ratio exceeding 1. So it's basically saying that we're overloading our section at that point. So we can see an individual report, and it's got some different data there. We can see the stress in the bars. Otherwise, we can see this nice summary report as well, which includes all the points. So there's our section there. Got some material info, including those stress strain diagrams we talked about before. But then here, what we can see is we can check our points. So this was our base section there, and we can see that we're just overloading. So this is our limit state that we need to be under for those given points. And then basically, if you keep scrolling down, you can see some interaction diagrams there that can be handy, and some points of interest as well. You can download this PDF if you wanted to record it somewhere. And then, if you wanted to also customize some interaction diagrams there, you can have a look at these different things here. There's the 3D interaction diagram, which can be handy as well. You can just rotate around have a look at a few different views there. Nice and handy. But what we might do, we might go back and just increase the size of some of those bars to see if we can get this passing. So we'll just go back to the rebar position, and we'll just increase these to, let's say, a number 8 bar, so 1 inch diameter. We'll change that to 1, and we'll just tick this line of bars as well, and we'll change this to 1 as well. And you can see that the size actually changes in this section as well. So if we now go back to analysis and run the ACI 318 analysis here, we'll see if we can get this to pass. And there you go. So we're now passing for that one. So yeah, you can download that report, as I said. Few different diagrams here. But yeah, hopefully that helps do some custom section design using the General Section Designer. If you have any further questions on any of that, feel free to reach out. We also have some documentation available here that you can check out, and that'll have some more information on the software in general. And yeah, thanks for your time, and we hope you have a great day.